Hey everyone, we're back with some more developer tooling talks, and today we're joined with Loris, who's been working on Kodama. Loris, you want to introduce yourself?
Hi, yeah, sure. So I work at Anza, um, the company that works on the main validator basically on Solana. But I work on like a separate team that focuses on developer tooling, and mainly on my daily basis, I kind of like help maintain Solana Kit, which is the successor of Web3.js that you probably know. And also working on Kodama, which is what we're talking about now, which is a standard for describing programs on Solana.
Awesome. So, if anyone was here for the stream a couple of days ago with Fibo talking about Pinocchio, Loris and Fibo work together and are on the same team at Anza. So, it's great to have you here and to have your time to talk about Kodama.
Thank you. Thank you for
Uh,
having me.
yeah. So, I just want to give a quick background of what Kodama is to everyone and what was like the motivation behind building it.
Yeah, so I guess in a nutshell, because Kodama can be so many things, it's very difficult to kind of like explain it in a nutshell, right? Um, but the way I would high level it as much as possible is it's basically a way to describe Solana programs in a way that everyone can understand, like machines and humans, explorers, and you can use it to generate code and things like that, right? So at the very core, it's basically like a AST like, so like some sort of like tree of nodes, like that would describe normally a programming language, but this time it's not a programming language it's defining, it's a Solana program. And it's trying to do that in a way that is completely framework agnostic. So if you're familiar, for example, with Anchor, you already are familiar with the system of like Anchor IDLs. And Kodama is essentially an Anchor IDL, except that it is not made just for Anchor. It is made to describe any program. And so we don't have like the luxury in this program to rely on like framework conventions and things like that. We have to like really describe things in a very structured manner, right? And so this is what Kodama does. And in fact, you can, if you have an Anchor IDL, and we'll show that in a minute in a demo, but you can convert that into an Anchor IDL, Kodama IDL, which you can then use to benefit from all of the things you can benefit from a Kodama IDL.
Awesome. So this is just a way to like generate IDLs for programs that are written with any framework instead of just like with Anchor. You can generate IDLs from Anchor, but only for Anchor programs.
That's right. And that's right. You got like two sides of it, right? The first side is like I have some sort of program written in any language, most likely Rust, but any language, and I want to get an IDL from this. And then you have the other side, which is, well, now I have my IDL. What do I do with it?
Mhm.
And the second part is where you would typically use it to generate clients. And by clients, I mean, say you have a program and you want to like expose a JavaScript package for your program consumers so they can actually start using your program um, in a way that is quite developer friendly and in a way that you don't have to manually write all of these instruction helpers and all of that every time you change something on your program as well. Um, and because it's kind of got decentralized knowledge of your program IDL, then we also have like a way to render Rust code. So like then if your people were using Rust as a client, let's say you had like a Rust app, then they could make calls to your program that way. And again, because this decentralized kind of like the IDL is in the middle, is the glue that binds everything together, then anything else is just one kind of like utility away. So anyone can then just write a Python renderer, which currently someone is working on, or a C# renderer, which again already someone is working on or has already created a version of that. And so it becomes this kind of like community tool. If we all agree in the standard in the middle, then anyone can contribute and the ecosystem can grow into something um, that actually provides a lot of benefit from people. And not just generating clients, that's just one part of it. But another part of it is um, kind of like making sense of bytes anywhere in the process of interacting with Solana, right? So, for example, if you're in the Solana program and you're trying, in a Solana Explorer, sorry, and you're trying to make sense of a transaction, then an explorer could try and crawl through the instructions of that transaction and figure out what programs are being used. And then if we have a registry somewhere where we have all of those Codama IDL stored somewhere, which is called a program metadata program, by the way, now, then the explorer can take that information, and then from that Kodama IDL that they retrieve from this, they can actually do a bunch of stuff such as show useful information to the user and provide decoded, um, data without actually having to know the program in the first place. And then I could carry on and like you can go into wallets and when you sign a transaction, the wallet could display more human-friendly information without actually having to know about the program itself and things like that. So yeah.
Yeah, that's awesome. Also, it looks like we have someone that was already looking at Kodama today and happened to fall onto this live stream, so perfect timing. Um, and then I'm curious, you mentioned Shank earlier, and I know people that have been writing native programs in the past are probably familiar with Shank. Can you, like, just compare, like, what's the difference between Kodama and Shank, and, like, how can they kind of switch over and learn?
Yeah, of course. So Shank is basically a way to annotate your Rust programs to output an anchor IDL. And that was a response, especially at the time at Metaplex, and I was working at Metaplex, and that's also why all of this is kind of like very relevant for Kodama as well. Is the solution at the time that we didn't have something like Kodama is, well, we have programs that are written in Anchor, we have programs that are not written in Anchor, and we need to write lots of clients for it. We don't have a huge team for writing clients. We need to automate this thing. So let's agree that we're going to use the Anchor IDL for now and patch that kind of like gap by writing this Shank thing, which was written by Thorsten, by the way. Uh, and um, and what that does is it passes your macros within your Rust program, and it outputs something as close as possible to an Anchor IDL. And then you can use the Anchor IDL to generate clients and things like that. So Kodama is kind of like eh, its decision to like break free from the framework, like added loads of benefits. And so we already can redirect Anchor IDLs to your Kodama IDL. So if you're using Shank to generate an Anchor IDL, then by extension, you can also use Shank to generate an Anchor IDL to generate a Kodama IDL, and then benefits and just plug in with the rest of the ecosystem. However, we are currently working on, and that's also something I'm going to show in the demo, something that is akin to Shank, but instead of generating an Anchor IDL, it would generate a Kodama IDL. And because the Kodama IDL is some sort of a superset of an Anchor IDL, then you'll be able to like give a lot more information directly within your program, which becomes the source of truth for everything that need to change. And then an ideal get generated from it. You can upload that into the registry and then generate client from it, and everybody's happy.
Awesome. And then it looks like we have another question in the chat. But what are the fundamental limits of Solana's architecture, and how does Kodama aim to transcend them? Also, how does Kodama address security vulnerabilities like missing checks?
So again, like Kodama isn't a framework. So if you're going to be writing your own program, you should be either using a framework that does some of those checks for you or write your own checks. And really, it's not something that I think Kodama really worries about in terms of like security. It's not that it doesn't worry about security. It's just that the goal of Kodama isn't to secure your program or anything like that. It's just to try and understand what your program does. And so if having checks and security kind of like boundaries set in your programs is something that is important for others to know, then that is something that can be included in future versions of Kodama in the standard, but it's not gonna affect the security of your program. That's something that, you know, you should like really aim to like perfect and audit your program and everything, right? Kodama is here to like, at the end of the day, when your program is done, secured, audited, live, you just sprinkle some information in your program that's going to be removed when it goes on chain. And that sprinkled information is going to be used to extract an IDL, which is going to be used to tell the rest of the world what your program does, and everybody's going to benefit from that. And like a clear benefit is anyone that creates a new Solana program and output an IDL and push it into a registry immediately without having to contact anyone or do a PR in some sort of repo somewhere. Suddenly, anyone that goes in any Solana explorers would be then able to um, pass information from your program, and it would look all nice and pretty in a Solana Explorer without you having to contact anyone, right? So that for me. That's the beauty of standards, um, and um, and yeah, I think security vulnerabilities kind of happen before that step. If that makes sense.
Yep. Do we have any programs live right now on the Explorer that has the IDLs published? Because that would be fun. I can
I'm not sure, to be honest. I wouldn't want to, guys, because I think Noah's been working on this, and I wouldn't want to put him on the spot if some of them are like not ready yet or something.
Yeah.
But maybe something we can do as a follow up, tweet or something. I'll reach out to him.
Yeah, for sure. Once it's live, I'll add some links in the description of the video, just
Mhm.
so people can check it out and see what it looks like on the Explorer because it's a really fun feature. Um, cool. Well, that's all of the questions we have in the chat for now. Do you wanna get started on the demo?
Yeah, of course. I think I should be okay. So I've prepared a little kind of like set of folders so we can just explore real quick. And we'll start with the different ways basically you can create a Codama IDL. And the most silly and obvious one is like, well, you can write one yourself, right? Like it's a bunch of nodes that makes up a JSON folder. And it sounds like a silly solution, but like a lot of the time right now, because the Kodama macro stuff is not yet ready, and we have to maintain a lot of programs that are not actually made with Anchor, writing one from scratch is actually the easiest solution. And because they're like, most of them are immutable, you write it once and then job done, right? It's not a long-term solution, but I kind of just wanted to use that opportunity to showcase what a Kodama IDL kind of written from scratch could look like um, as a result. So let me just do open that up. Uh, where's that? Right. So the only thing that really matters here is this IDL.json, and this is the thing that I've been mentioning, where you can write brand new yourself, and maybe that's a good opportunity to go through real quick how it's laid out, right? So everything is a node. So like it's a tree of node, and a node is just an object that has this kind property that tell you what type of node you're dealing with. And the one at the top that creates your standard is called the root node. As you can see, the root node has got a program, which is the one that you're trying to describe in this case. But it can have additional programs within that same node. And that's useful, say, if your program depends on other program types. So if it's using a PDA that's coming from another program, this is a good way for you to kind of like put some of these things so that your program I- IDL is kind of sufficient. When you have your JSON, you don't have to like start to talk to other IDLs. You can just like cache out all of the bits from programs that you use outside of it. But mainly, what you're going to be most of the time writing your IDL on is this program attribute, which again you open, and it's another node which is called a program node. And this time, this is where you're going to have all of your instruction, your types, your accounts, your errors, and some of your metadata, like I don't know, this public key and the version and things like that, right? So um, then, like, if you go into types, for example, then you have a define type node, and this particular one is called like a version for the nonce accounts, and the type is an enum with different variants. And this is kind of how you go and have more and more nodes that describe more and more types and more information. So I'm not going to go through all of this because that would be super boring and last hours. But this is just I just wanted to kind of like show an overview of what a Kodama IDL actually looks like. If you'd not kind of like seen that before. Um, and so say you've written this from scratch, right? Why not? Then what you can do is you can use that to generate clients. So I've got like a very empty package of JSON, nothing like literally the npm in it. I would put it this. Um, and something else I've got here is just some boilerplate for the clients that we're about to generate. Ideally, some of these things, so you can see there's nothing, right? So like the source folder has an index.txt and it's exporting this generated folder that currently is missing from here. And then you've got this package of JSON, which says, oh, actually, well, you need Solana kit in order to use this package because this JS renderer uses Solana kit under the hood, right? Um, Ideally, I think there is a case, and there's already like an issue on GitHub about maybe we should aim to generate that package of JSON and maybe that index.ts file like the first time you try and generate your client. So you can go from like having nothing, like no boilerplates, to having a full boilerplate. But also we have to be careful because people on top of their generated folder, they might want to like write manual code and write stuff that's a bit more advanced and like higher level helpers and things like that. And that means that they might need to add the additional dependencies. And so they need to have control over their clients. The only file that gets deleted and regenerated every time is this generated folder, right? Um, but there's definitely some improvements we can do on the renderers eventually to at least make it a little bit simpler to get started. Right now, you've kind of got to kind of like create a JSON package of JSON and add these dependencies for it to work. Um, and on the Rust side, you have basically the same, right? You've got this equivalent, which is the lib.rs. And right now, this is nothing at the moment. And then you've got this cargo tunnel with a bunch of dependencies um, that are going to be used within the generated code, basically. So this is going to be yeah, the boilerplate. So now, and we have our ideal. So now we have these two things. We can basically generate those clients and fill those generated gaps right here. So what I'm going to do is I'm going to start by installing Kodama. So we're just npm install Kodama. Sorry, install Kodama. And now that I have Kodama installed, I can access the CLI. So I can just do Kodama help, and you can see that right now we have got two commands in it to initialize a Kodama kind of config file, and then run a bunch of scripts from it. So if I do Kodama init, it's going to ask me a bunch of questions, such as where my IDL is located. Well, right now my IDL is actually right here, so IDL.json. And then it's going to ask me
Wait, one
what.
second, Laura.
Yep.
You just make your terminal a little bit higher. The name of your screen is covering it on the stream.
Oh, I see. Gotcha. Maybe like this. Is that okay?
Yep,
Cool.
there we go.
Um, all right. So then it's gonna ask, um, yeah, which script preset you want to use, and essentially what client do you want to generate using this IDL, and you can toggle this on and off. And right now we're gonna do both of them. And then it's going to ask a bunch of questions based on the one that you selected. So like, where do you want to generate the JavaScript code? And same for the Rust code, right? And then because you've selected the JavaScript and the Rust um, renderers to generate clients, is going to understand that you are missing the renderers JS and the renderers Rust packages, which are required to generate those clients. So it's going to ask you to install them, and you just say yes, and it's going to install them for you. And then you're basically done. So now that you have this, if you go into, let's say, the GitHub desktop, we can see what was created. So first of all, we have Kodama and the renderers installed to their latest versions. And then we have a new kodama.json file, which is the configuration list. So it kind of like starts with where your IDL is. and then it creates a bunch of scripts, much like you would have in a package or JSON, for example, except that it runs visitors from your Kodama IDLs, and the renderer JS package is a visitor that generate JavaScript codes, right? JavaScript code. So you can see we've got the JS one and the Rust one, so everything is all set up. And now what we can do is we can go ahead and run those scripts. So I could go and just say Kodama run JS or run Rust, and it will run those scripts, therefore generating those clients. But I can also just do all, and it will do everything for me. And so now if I look at the diff again, you can see I've got loads of new files, and these are basically the generated code that have been generated for both Rust and JavaScript. And if I look at my code base, you can see that they're here, and you can see that they are here as well. So
Awesome.
yeah, that's how you can generate. Ooh, don't know what happened there. I guess I just closed my. Yes, good. Okay, so yeah, that's how you can basically create those clients. But again, that was, coming from an idea JSON that we wrote from scratch. Realistically, how many people are gonna want to write IDLs from scratch? Probably no one. So so that brings us to the next step, and this is then going to look very similar. So I'm going to go a bit faster, but the only difference, we're still going to generate JavaScript and Rust clients from them, but the only difference is going to be how we get that IDL in the first place, right? So so for our second kind of like part of demo, we're going to come from an anchor IDL. So in this case, if we look at what we've got, uh, maybe if I do this, is going to be big. Yeah. Um, so we have got an IDL, but this time it's your typical anchor IDL that you probably recognize the shape of a bit more than the Kodama one. And uh, the rest is exactly the same. So that means we have a package JSON that's completely empty, and we have a bunch of boilerplate that is also empty for our clients, just so that the generated folder can be next to an actual package or Rust crate. So now what we're gonna do is we're gonna do the exact same thing. So we're gonna do pnpn store Kodama, and we're gonna run Kodama in it. We're gonna tell it idl.json. We're also gonna select both JavaScript and Rust clients, and we're gonna locate them in the same location. And this time, on top of asking you to render to install the JS renderer and the Rust renderer to generate the clients, it's also asking you to install nodes from Anchor, because it kind of like detected that your IDL wasn't a Kodama IDL, and so it's inferring that it's an Anchor one, and that you need this package to convert it from an Anchor one to a Kodama one. So you just say yes, and it's gonna install all
Really
these
helpful.
things. Yeah, that's I've really been trying to like this basically all of the works of getting started with Kodama. I'm really trying my best to like have them abstracted away with the CLI. So again, any feedback when people use it would be great.
Yeah,
Um so
also,
yeah, otherwise yeah.
if anyone's watching this video later after trying out Kodama, and you have feedback, leave it in the comments, and I'll make sure Loris gets all of the information. But we do have some current feedback, and it's smart, simple, and easy to use, so going well.
Nice. Thank
Um,
you. Yeah, that's a good shout about reaching out to people from the future.
yeah.
If yeah, we did all the help we can get. Um, so yeah, basically at this point we are at the exact same point as we were before. We have this Kodama JSON config file, which looks the same. So looks exactly the same. This IDL.json. The only difference is that Kodama knows that this IDL.json doesn't look like a Kodama IDL, so it knows it's an anchor one. So every time it does something before generating your clients, for instance, it's gonna first convert it into a Kodama IDL before moving forward. So we can test it. we can do Kodama run all of our scripts. And then the same happens. And again, we have our generated folder here and um, our Rust generated folder here. And by the way, this was a different program. The first one was a system program, and this one is a stake program. So to show a little bit of variety. Um, so yeah, that's for that. And then the third and probably most excited way to create a Codama IDL, which is not fully ready yet, which is the caveat. It's going to be from macros. So in this case, we have a little bit more. So let me close this so I can reopen it in full size. This time we've got so we still got our boilerplate for the clients, which I've already mentioned. Let me just read this thing, and we have a program. So we don't have like an IDL to start with anymore. We just have a program, which is more useful than having an IDL from somewhere else. And this is actually somewhat of an interface for the system program. So we're gonna have this lib introduction points, and for example, if we go to states for where you'd have all of your accounts, then you would describe your accounts like you normally would, except that just like you would do with something like Shank, you would annotate it so it says Kodama accounts. So you're telling Kodama, okay, this particular struct here, it should be identified as an account. And then, like this particular account is using nonce version and nonce state, and both of these things are enums, which are represented um, um, as Kodama type, right? That should be exported as such, which is why you have this Kodama type macro here. And also you've got that representation U32 because in the system program, those enums are actually using 4 bytes to as like a size for their value. So instead of having like if this was legacy, for example, it would be 0, but like on 4 bytes and 1 on 4 bytes. Probably some alignment reason for having this. So that's why Kodama is kind of able to understand that because of this, we should change the way we describe our type when we export it as a Kodama IDL. And then same for errors, it works also with stuff like this error to kind of understand and grab those information from this errors. But if you didn't want to use this error, you don't have to. You've got like a Kodama error thing that you can use instead. Um, and then for instructions, you've got the same. Got this Kodama instructions with a S. You also got instruction without the S if you didn't want to use an enum to describe your instructions, but in this case, that's the simplest because that means every single variant of the enum is the discriminator that will automatically be injected for these instructions, right? And it works by having obviously the data inside and then the accounts as macros on top of it. And so you can say if it's in Solana, if it's writable, you can even say, oh, it's got that default value. Default value you can get a bit funky as well. So you can say, oh, this is that particular sysvar, or this is that particular pub key or program, things like that. But yeah, otherwise it's if you're using Shank, it's very similar. And right now I would say it's about on par with Shank for feature parity. But there is a lot more that I would say this project is probably like 10% done and it's already on par with what Shank can do.
Tough.
So there's a lot more you'll be able to do. Essentially, like ideally, I never want you to like have to go into your Kodama IDL and tweak things yourself. I want everything to be like right next to your actual code in the program, um, which will be super helpful. And like actually, this is probably an interesting one to notice is by default, if you just use string, Kodama is gonna infer that this string is going to be a UTF-8 encoded string, which is what most people use, and that is going to be um, prefixed with a U32 number, so we know the size of the string, so we know when to stop reading it, so we know when to actually go and grab the next attribute, right? In this particular case, when you go and do the transfer, so with seed instruction, for instance, that from seed is actually a fixed, the size prefix is actually not a U32, it's a U64 instead. Again, probably for alignments. So with Kodama, you can actually add those modifiers at the top, and you say, "You're right to saying that this is a UTF-8 string, which is prefixed with a U32. The only thing that's different, that's not actually quite correct, is that it should be a U64 instead for the size prefix." And this is what is really fun about Kodama is you can then start those Kodama macros is you can start to change some of these modifiers, and you could say, oh, I don't know, the encoding is actually not UTF-8, it's probably base 58 or something, right? And this would actually also update the thing. So that's what I mean. All of these modifiers and these overriders and all of these things have to be written. And right now it's about 10% of them written. But if your program is kind of able to support Shank, then you should be fine using this. So yeah, that's basically the tour of how you would use Kodama macros on your program. Right now, there isn't a CLI for it. And that was my main priority until Joe from Anza, also a colleague, said to me, well, why don't you just write a build script? And then therefore your IDL is automatically generated whenever you build your program, which sounded really fun. And he showed me how to do this. And it's so I've added that here. And so I'm still planning on doing a CLI, but kind of pushed it down a little bit in the priority list because it's so easy to do actually. And this is actually on a repo somewhere, so I'll share the link if you guys want to see the code. But yeah, the idea is that you have this generate IDL function, which gets called in this main thread here. And all you do is you start calling the Kodama API. So you have this Kodama object that you can, or struct rather, that you can call the load function on, and it's going to load the path to your crate. And it's good to know that you can actually provide multiple crates. You don't have to provide just one. I think there's one called load all, and then you can provide multiple crates. Because sometimes your program might actually be split into multiple crates, and you just want an IDL that goes through all of these crates and generate an IDL for it, and that's fine. That's supported. Um, and then what you end up with is this Kodama kind of objects that you can do a bunch of stuff with. And obviously the thing that you're most likely going to want to do is get the JSON IDL. And then when you do, you have this string and then you just, format it and write it in a file somewhere. And then you're done.
It's awesome. I
Um,
know,
yeah.
Chris, you can't see the chat, but you did preemptively already answer a question. One was,
Oh,
when are we creating CLI commands to be available on Kodama? So there's the answer. Um, and I will update the description in this video to have a link to this repo so you can pull this build script down and use it. Yeah, just answering that question. And
thank you.
since we're going through some questions really quick, just
Yeah.
some more feedback here. Some more live feedback is Kodama is really good and simple to use. And then another thing not really related to Kodama, but asking what is the screen size of your Mac, Boris?
So that's I'm using the monitor. I'm not sure which one it is already, but it's like a Apple monitor, which is 27 inches. But I am zooming to the max. So for me, it looks like I don't know. It looks massive. Like I've got characters that are probably I don't know 40 pixels or something.
It's crazy. Yeah, you have to always zoom in so much when you stream, so yeah.
Yeah, I actually I used to have a software. I couldn't find it anymore, but I would change the entire resolution of your screen for stuff like this.
Oh, that's
But
cool.
yeah, I don't even know what it's called anymore. It was really good though. Um, but yeah, actually, one thing I wanted to mention as well is this is the very simple stuff. You load your crate and you get a Kodama object, and then you use that for Kodama to scroll through your code and extract that IDL from your code, right? But you can also load plugins into this thing. So there is this function called add plugin. So you would just do something like dot add plugin like this, and then you can add as many plugins as you want. And why this is important is because Kodama, as I said, is framework agnostic, but that shouldn't mean that if you're using a framework for your program, um, we shouldn't be able to kind of like piggyback on some of those conventions that your framework offer in order to extract more information without you having to add macros into anything. So if you're using, I don't know, an anchor, it sounds really weird to be using anchor because obviously you can already do from an anchor IDL. But say you were using like a steel framework, right? And that doesn't exist at the moment. But say you had a steel framework plugin that was existing, and that plugin, what it would technically do is it would say, it would basically inject some additional information to this whole machinery, and it would say, well, for example, if you're creating a struct that finishes with the word accounts, then trust me, this is going to be an account. You don't have to annotate it with the macro, the account macro, the Kodama accounts macro, right? So this is just completely speculative. I don't know if the Steel framework does that, but this is just an idea to show that by adding plugin into this machine, you can reduce the amount of macros you use. You can still use macros on top of this to kind of like override or modify some of the default values from this framework. But I think this is very important because that way, all of the frameworks can like decide to create their own Kodama plugin, and then they never have to worry about offering an IDL because they can just work with Kodama to get one, and that's one less thing that frameworks need to worry about. They just need to worry about how I'm gonna extract more information from my Rust code, basically.
Yeah, that's awesome. It definitely makes things a lot easier because now there's, like, one ideal to point to, no matter, like, what framework that you're using, so I love that.
Yeah, and actually to touch on this, right? It's and a lot of people have kind of asked me, "Oh, do you think that Kodama IDL like should replace, Anchor IDL or any IDLs frameworks might create?" And I don't think that there is any kind of like conflict between those things, right? Like the goal of Kodama is to be this standard that is framework agnostic, and yes, ideally you can use it to extract an IDL from any framework if the framework offers a plugin, right, to extract that information. But say there are situations that are completely valid where a framework may want to offer its own type of IDL, because within the domain of this framework, some things might be very specific to that framework and might make no sense to live in a Kodama IDL. And by not having this information, the framework would suffer from some of the utility it could provide. So I don't think that the two are kind of like mutually exclusive. I think they can all live hand in hand together. Is what I'm trying to say, basically.
Yeah, that's awesome.
Um, so yeah, enough about all of this stuff. I've shown you the build script and the state thing. And actually, as you can see, because I've probably been saving as like a bit of a OCD, man, like I just save all the time without realizing I'm saving.
I do the
It
same.
it it had actually built this thing, so there is already an idea that JSON thing that was added. But I believe if everything goes on, I remove it, and then I go into, so I do cd program, and then we call bro build to be a bit more explicit. They say, yeah, idea was written to program slash idea.json, and we should have it back right here. And we're back to our, root node that we've shown earlier. And then from there, then nothing new here. We can just continue to do the npm install Kodama init. This time, the default is actually correct because we do have an ideal JSON inside the program. We're going to run everything. We're going to install our dependencies, and we're going to do Kodama run all, and we've got our generated clients. So yeah, that was basically all the ways that you can currently get an ideal, a Kodama ideal, and what you can do with them.
Yeah, that's
Yes.
awesome. I also love the way that the CLI is currently. It just is very intuitive, like, kind of walking you through each step and, like, letting you know when you need to install additional things and giving file paths for where things are generated. It's really helpful.
Thank you. Yeah, there are still, I think, still things we can do to make it even better, but like it's just like always constant improvements. And I think um, as soon as people start using it a bit more heavily, then this is where we're gonna get like true edge cases and things like that. So I'm really looking forward to that.
Yeah, definitely. Again, anyone that's watching in the future, testing this out, leave comments in the description because I will be checking them, and giving the feedback over to Loris. Also, another thing I wanted to talk about is this seems to be like a common trend, whenever we're talking about tooling and projects is a lot of people watching are curious, like, how can they contribute? And just trying to, make contributions to the ecosystem. So what is, like, any advice or guidance that you have if someone's looking to contribute to Kodama?
That's a good one actually, because there are many different steps, right, in which you can contribute to Kodama. You could add a plugin to the machine that extracts an IDL from any cross code, or you could add a new renderer because maybe you want to support a new language, or maybe you want to support the same language but with a different framework. Maybe you don't want to use Solana kits and you want to use only Gil under the hood, and maybe you want to create um, I don't know, a renderer that just use Gil. It would make little sense because Gale works with Solana kits anyway. But that is, like, just to illustrate the point, right? Um, and of course, you can contribute to the standard itself. So, like the way nodes are created and the way nodes interact with each other. Or you can contribute to visitors. Visitors are basically these functions that crawl through your Codama idea. So they go through your entire tree and they either update it or they output some additional information for you to use on a different visitor to do some more information. So all of these things is like this huge machine and you can contribute on any steps of it. Um, but I think probably what most people are going to be looking into contributing, especially at the moment, because we probably have like 3 or 4 visitors right now, and we need more than that. It's going to be writing renderers, right? In order to support more languages and more frameworks out there. And actually, in right now, I'm working to help improve people contribute in that way. So help people write more renderers because right now we have got a very complicated JavaScript renderer because it's pretty powerful. It's like it's doing a bunch of figuring out the default values, and if an account default on another account, which defaults on another account, which defaults like on the value of a public key argument. All of these things are kind of like resolved, and this one is way too complex, I think, for people to just copy paste. And then you've got the Rust renderer, which is a bit simpler and a bit better for people to start reading and copy pasting to start their own thing. But the Rust renderer also doesn't support the full of the Codama IDL. So then all of the stuff that we do in that regard gets if you copy paste like the Rust renderer, then you will inherit from its limitation before you've even started working on it. So what I'm trying to do right now is create a brand new demo renderer, which is basically just going to output some simple markdown for your account, instruction types, and errors and PDAs, so that you can have a look at the full kind of like concept of how you would write a renderer, but without being overwhelmed by all of the things that the Rust and the JS renderers do right now. And then my next step, what I'm trying to do is after that, I will aim to extract the renderers into their own individual repos. So it's easier for people to just fork an entire repo and then have control over their own renderer. Because we don't need to like everybody at the moment, they try and PR and you render into Kodama. But if you PR into a render into Kodama, and our team, for example, doesn't have maybe the resources to maintain this particular language, then you're going to be the one anyway continuing to maintain this render inside this repo. And maybe it just makes sense for you to own your own repo and have maintain it, and it will just work. And that's also why the CLI, all the changes we've done recently with the CLI about automatically detecting the renderers that you need, is also a way to decouple Cardano from the equation and let the community just create their own renderers, and they will be automatically required to install them, which is really cool.
Yeah, that's awesome. Yeah, so there's quite a lot of ways that you can contribute. Find like the path that works for you. And there's also a lot of potential edge cases that could come up as you're using Kodama. So again, if any of those come up and you have feature requests or comments or feedback, let us know. Yeah, awesome.
Yeah, and there's probably about like 60 issues on the Kodama repo because I use the issues a lot to kind of like write proposal. I literally have like a proposal tag, and every time I have an idea about like how Kodama could be better, either like on the standard, on the render, or I usually just write an issue there with the proposal and just wait for people to kind of like chime in and give their opinion. And right now, there's a lot of tumbleweed, but I'm sure like soon enough, people will start adding their opinion on this, which I'm very much looking forward to.
Yeah, definitely. It's awesome.
Yeah.
Cool.
So I
Thank
stop sharing my screen, by the way. Or
Yeah, that
yeah.
works.
Yeah.
Um, yeah. Thanks for going over everything. This was super helpful, and I'm sure, like, if anyone has been watching this that hasn't been aware of Kodama yet, now they're gonna wanna check it out. Is there anything else that you wanted to go over or, like, touch on before we close up?
No, I think that's everything for me. Yeah, just hope that the community grows around this project because I think it's going to benefit from both sides. The project's going to benefit from the community, and the community is going to benefit from the project. So, yeah,
Yeah, definitely. I'm excited to see, what becomes of it. As you said, it's only in its beginning stages right now. So, I'm excited to, like, test it out and see how it grows in the future. And yeah, again, anyone that's watching, leave your feedback. We're going to update the description with, some GitHub repos and some documents and just any resources that will help you with Kodama. So that'll be updated soon. And yeah, that's everything from me. This was super helpful. I really appreciate you coming on and taking some time to chat. So thank you.
thank you so much. Thank you for having me again.
Yeah.
See you later.
Thanks, everyone.
Bye.